Hi there, I'm John from CNCKing.com, and today we're going to laser engrave a solid oak door. Now this isn't something that happens too often, but every once in a while we get a project that's far too big to fit into our machine. So the way around that problem is actually to feed it into our machine. So that's what I did here. This is roughly, I'd say, 1.5 inches to 2 inches thick. Solid oak, so it's maybe 200 to 300 pounds. So it's very, very heavy. And it actually exceeds the weight that you can actually have the machine hold the material up. So that's why I have sawhorses, which you don't really see on the video, but you can see the edge of here. So I have two sawhorses, one in the front, one in the back of the laser. And between that I have 2x4s. So I have this support all the way through the laser. And then on top of that, I have my spacers here. And what the spacers do is, lasers are affected by density of material, which is oak, in this case here. But there's variations in the density. So one issue with that is that I'll get different heights for the engraving because the denser the material, more power is needed to get the same height as somewhere where it's less dense. Now something that affects that really bigly is the height of the material relative to the laser head as well. So if I didn't have this level, the problem I would have is that the laser would produce maybe a lot of charcoal, but not a lot of depth in some areas, or a lot of depth and not a lot of charcoal in other. Like there'd be a lot of tremendous amount of variation in the laser engraving. And you can't really have that because it kind of looks kind of crappy. So the way around that is to put everything on sawhorses, make it level and square as much as you can do it. And then after that, you have the same height for at least the laser. So you remove one sort of area of air that would be the height of the laser being different in different areas. Because this is perfectly parallel to the laser head. So after that's done, basically what you have to do is feed it through the machine. So you do a section of it. Then once that's done, you either push this forward, or I've done a couple of times as well, move the laser forward. Because remember, the laser is not anywhere touching or anything like that this material here. This material here is on sawhorses, and the laser is independent of that. So the challenge when it comes to making a project this large actually come to fruition is really what's around it. Meaning that when you have something that's too heavy for the laser, how do you hold it? In this case here, I have two sets of sawhorses. Each one is rated to over 1,300 pounds, and these doors are roughly 250 pounds. So worst comes to worst, one breaks, I can still hold the wood over the laser. Now I use two 2x4s on their edge, and that can hold a tremendous amount of weight. Can't hold 1,300, but I'm so overkill for everything else that I was fine doing that with that process. And when it came to doing the laser engraving, you'll notice right away I'm going multiple passes, and this is really sped up by quite a bit. And the reason for that is the first pass just sort of breaks the surface, gets a little bit of depth, second one gets more depth, and third one gets even deeper. Now on some of these panels here, I actually had to do 4 passes. And it doesn't really matter when you do the finishing, you won't notice the depth difference on a hard material like oak. If I was doing like a soft material where you're basically going down, 1/8 inch each time, you'd definitely notice that there's a difference in depth. And the reason for that is because when you do the finishing, what you're doing is removing the smoke and the resin, all the other stuff off the top layer. And because of the density of the engraving on this wood here, a little bit of depth variation you really wouldn't notice. And anyways, you got to keep in mind that you still get the depth variation regardless. And the reason for that is because the laser works on the material density. So the denser the material, the less depth you end up achieving. And what I was trying to do when I was doing this project was making sure that I had roughly 1/8 inch of depth, plus or minus a little bit. But I erred more on the plus than the minus, because my biggest fear whenever I do projects like this is that they run it through the belt sander and then they find out they took all the engraving off, so basically I have to redo it all over again, and that's not any fun. I've never had that happen to me, and that's because I tend to underestimate the depth or overestimate the depth, whatever, to get it all the way through. Now the customer provided me the doors, and in this case here they're laminated, and that's actually a really good plus, because when you have laminated wood, generally the glue is stronger than the wood. It's just like welding. You know, where you do the weld is actually stronger than the metal around the weld. And that's very important because the last thing you want to do is put a solid piece of wood, hang it as a door. That's what these are here. And then have it start warping on you. And so by splitting up the wood with some glue in between the different grain textures and patterns and all that kind of stuff, you end up tremendously reducing the risk of it starting to warp on you. And this is really thick and heavy, so that all goes in the favor of reducing the warping. Now, when I was doing this project here, you notice I get a couple of different angles here and there when I'm doing the engraving. That's because of the size of my shop, I had to move a lot of stuff around to be able to move these doors around. So I had to move stuff here, move stuff there, and I would never get the same camera angle working properly. And also when you do the laser engraving like this here, you're also moving the laser and you're adjusting the height, so that basically every time I touch the wood, I had to make sure that it was parallel at the same height on all four corners of the welding area or the engraving area whenever I was doing the engraving. So if I had roughly an inch and a half in each corner, and then I know it's flat, parallel, and proper. And that's how I did the whole project. So there's a couple of ways around sort of this issue of feeding something through the machine. One way is to make it as panels. So for instance, you know, if I made a door and I had, let's say, a frame going around it 4 times or 3 times. In this case here, this door is roughly 96 inches by around 38 inches. What you do is just do a panel, laser engrave it, and then you do a different panel and laser engrave it, different panel and laser engrave it. That's a nice way to get around a lot of issues that you have when you have a large piece like this fitting through a machine. Another way around that would actually be to do it in small squares. So the design itself, instead of being one solid design all the way through the door, you'd have like little squares of, you know, the laser engraving, or triangles or whatever. So you can modify a design so that it's a lot easier to laser engrave rather than going through a full coverage like this. So when it comes to designing something like this, every way has a plus and a minus. We made a huge stainless steel vault about 2 or 3 years ago during COVID, and that was done using panels instead of a large piece like this. The reason for that one was that it was stainless steel, and it was far in excess width-wise to what can actually be fed into the laser, so we had no other choice. So something we considered for that were larger panels, but we ended up going like panels sort of like this. And the reason for that is because stainless steel likes to warp from all the heat, and that's something that's nice about wood this thick. It doesn't want to warp on you from heat. It just warps on you naturally. So that's why, again, I went with the sawhorses in this, because this is not perfectly square, level, or parallel. I have to adjust it a little bit so everything is proper to the machine. You also have to keep in mind that it doesn't mean the floor in the shop is flat either. So again, you have a lot of things to consider, and that's why at the end of the day, the easiest solution was to do the sawhorse idea. Now this isn't the first big door project we've done. I've also done big, huge doors like this out of stainless steel. I did the vault for a big company, GitHub, in Scandinavia. And for that was stainless steel. And we ended up going with plaques that were welded onto the stainless steel vault that we've also built. And in that case there, that was a huge advantage over wood, because you gotta remember, wood is great for interior stuff, but no matter what kind of finish or stuff you do to wood, you put it outside, it starts to degrade. And especially when you do laser engraving, that kind of stuff, what you're doing is creating sort of holes and pockets in the material. And that's why you see a lot of this kind of work end up having resin over it, but resin's plastic, you put it outside, you end up having other issues as well. So if you really wanted like really cool doors, but for outdoor use, I'd go with stainless steel, I'd go with metal, I'd go with all of that. And for indoor use, either one is totally fine. Now the resolution you get with metal versus wood is pretty much the same. There's not much of a difference. They're both engraving, and for the wood they're engraving, for the metal they're etching, but it's the same sort of black and white imagery, either laser on or off. You don't want any grayscale, and the reason for that is because as soon as you have grayscale, you have a muddying of the resolution, muddying of the contrast. And if you have a difference in depth, but it's more like a smooth transition back and forth, you end up just getting a really muddy thing. While if you notice here where it's laser engraving right now, it's black, or in this case dark brown from the charcoal of the oak, and then it's just the charcoal surface. Now what the finishing does is it removes all the stuff that settles on the surface of it, and that evens out a lot of the color, because you got to remember, where there's a lot of laser engraving, there's also a lot of smoke being deposited on the surface. And what the belt sander does, it just removes all of that and makes everything nice and even. Now you notice again, this is laminated, so you do have variations between the boards. So on one of the pictures you can maybe see there's a seam where it's a lot darker than everything else. And the reason for that, of course, that piece of laminate, or the solid oak that's laminated, that little piece actually has a different density than the wood around it. It's actually less dense. Therefore, it's getting more depth. Therefore, it's creating more resin and smoke. Therefore, more of that was selling everywhere else. But again, you can fix a lot of stuff in post, just like movies, and it comes out really, really nice. Now, we actually did 2 doors in this case here, so it's twice the amount of work, and it takes a tremendous amount of time to actually laser engrave the depth in here, because unlike a router like you have here that this table is sitting on, a router can control the depth, the laser cannot. So basically you're laser engraving over it, and if you happen to hit material that's very, very dense, well, that means you have to go over the whole thing over again to get the depth required, because what the customer will do is they're going to send this to a mill working company, and they're going to run it through a belt sander that will clean up all of the stuff on here. So this looks a little bit messier than it should be, and the reason for that is because all the smoke and stuff from the laser engraving settles on the surface. Now this is a great example that shows you the different densities and what happens with the charcoal. So you can see here there's lines, and that's not the laser doing that, that's the material itself. Oak is a natural material, and because of that there's some variations in what the laser does charcoal wise on the surface of it. Now once they sand it and they finish it, it will sort of even itself out a little bit, but if you look for it, you'll always see that kind of stuff. A way around that is to use a man-made material, or something that's very, very consistent density wise, and of course texture wise and so forth. And generally that excludes wood. Corian is a great example of something that's completely consistent, and another way around that is of course paint filling. But for something like this to do a lot of paint filling, the problem with wood is that it tends to bleed throughout on the surface of it and through the grain. So plus or minus depends on what you're doing. So if you're looking for custom laser engraving, contact me at CNCKing.com. We'll make it for you and ship it right to your door.